Now let's look at quadratic functions in context. And actually, quadratic functions are the most naturally occurring functions in the world around us, like the path of a football when it's thrown, just that pull of gravity. And another example I have here is water from a fountain. Just when we throw something up and that soft curve as it falls back down is a quadratic function. So let's look at some examples. Number one, Andrew launches a toy rocket from a platform. I'm going to go ahead and label over here. This is going to indicate Andrew on that platform. The graph shows the height of the rocket h feet after t seconds. Question A, what is the rocket's initial height or starting or beginning height is what initial is representing. So looking right there at that y-intercept where I already labeled platform, what is that height? And think about our x and y coordinates. So we've got at 0 seconds, 52 feet. So therefore, the initial rocket's height is 52 feet. Question B, how many seconds have gone by when the ball is at its highest point? What would that represent? Our vertex or our maximum point here? So here's our vertex. It is serving as a maximum for this context. How many seconds have gone by? Looking at our x and y here, it's 3 seconds, 196 feet. So at 3 seconds. What is causing it to lag so much? Question C, what is the rocket's greatest height? We already used that term maximum for that vertex point. So what is that maximum height? 196 feet. Just looking at that vertex there, the y value or the height in feet is 196. And D, how long is the rocket in the air? From platform to when it crashes on the ground, it's going to be all of this time here. So from 0 seconds to how much? 6.5 seconds. So in total, 6.5 seconds it was in the air. For number 2, Jeremiah kicks a football. The graph shows the height of the football, h in feet, after t seconds. On Delta Math, you have some drop-down lists here, but we're going to talk about the x-coordinate and y-coordinate of our vertex and what they represent in this context. So the first part, the x-coordinate or t-coordinate in this case, because we're still talking about time in seconds, of the vertex is, what is that value? Again, we're looking here at this vertex or this maximum point. This would be our x and our y. So the x coordinate of our vertex is 1.4, and it represents how long the rocket has been in the air. And then there's another drop down box at this point is at its vertex or at its peak. How long the rocket has been in the air at its peak. Okay, second part, the y coordinate of the vertex is 31, 36, and it represents the rocket's height, right? The y coordinate is for height. Where or when? Well, we're at the vertex or at its peak as well. Okay, so simple as that. Taking the x coordinate, what did it represent? Time or how long the rocket has been in the air. We're talking about at the vertex, therefore at its peak. Y coordinate is height in feet, so the rocket's height. Where? We're talking about the vertex at its peak. On page 2, we're going to look at some functions in context, but we're going to use our calculator to graph it so we can pull out some of this information and apply it back to our context. Let's start with number 3. The company sells widgets. The amount of profit, Y, made by the company is related to the selling price of each widget, X. Notice I'm going ahead and just really confirming with myself, what does X stand for? What does Y stand for? Y is the profit. X is the selling price of each widget. And we've been given the following quadratic, y equals negative x squared plus 62x minus 410. Using this equation, find out the maximum amount of profit the company can make to the nearest dollar. So if I'm looking for a maximum amount, what is that? That's going to be my vertex. And I'm looking for profit, going back to my problem, that's my y value. So this question is asking me to find my vertex and identify the y value of that vertex, which is going to represent the maximum amount of money or profit the company can make to the nearest dollar. Okay, let's do that. Let's grab the calculator. Remember, we're going to go to a new document from our home screen, and we're going to use graphs. I'm going to type in negative x squared plus 62x minus 410. So right now our graph looks like a blue line, even though I totally just graphed a quadratic. We are working with some very large numbers here. So on our graph view right now, it just is a very small segment and I can't get the whole picture of it. So looking at our calculator steps on our notes, the second one I gave you is to zoom in or out, or specifically, I'm going to show you how to use zoom fit, which is going to try to fit the graph or the data into our screen. Okay, so let's go to menu. Number 4 is window zoom. And here you do see that zoom in, zoom out feature. My favorite is zoom fit. Towards the bottom of the list, zoom fit. So next, what you can do is you can move your graph. We can hold down that center button to grab our graph. So let's move. I'm going to use the touchpad. I'm going to move closer over here because I'm definitely going to want to pull it that way, right? Press and hold that center button. As long as you had a cursor, like a mouse cursor, click and grab. And then you can use that touchpad to pull it over where you want to see it. And then to let it go, just press and hold that center button again. And I'm starting to get very close to our vertex. I'm going to go ahead and use that trace feature that we talked about in the last video on menu. Number 5 is trace. And then graph trace is going to put a cursor on the graph for me. And I'm going to see if I can go grab that vertex. There it was. Did you see it highlight the maximum there? Let me backtrack a little bit. It's going to show you a yellow box for maximum. It doesn't say vertex, it says maximum. And that is my vertex point because it is the highest place. And in the bottom right corner, we see 31,551. Okay. We were being asked about the profit. So the Y value, $551 is the maximum profit that this company could ever make based on the selling price of each widget using this quadratic function. Question 2, using this equation, find out the price, that's X, right? The X value. The widget should be sold for to the nearest dollar for the company to make a maximum profit. So we're still talking about the vertex. So we just finished looking at that vertex on our graph for the Y value. What was the X? 31. So each widget needs to be $31 in order for them to make a maximum profit of $551. Let's try again with number 4. A rocket is launched from a tower. The height of the rocket, y, in feet, is related to the time after the launch in seconds for our x value by the given equation y equals negative 16x squared plus 124x plus 127. Using this equation, find the time. And what was time? Time was an x value that the rocket will hit the ground. Okay, think about our graph. We're not talking about vertex. Vertex is not where it hits the ground. Where is that? That's going to be at a root or an x-intercept. So we're looking for an x-intercept. And then we're going to round to the nearest hundredths of a second. All right, let's put this in our calculator. I'm going to do Control Doc to add a new page, add graphs, and this time we have negative 16x squared plus 124x plus 127. And graph. Ooh, still not a good picture, right? Let's try menu, window zoom, fit, and see if that helps. Ah, a much more beautiful parabola. All right, we are looking for where it hits the ground this time, right? So I'm going to grab it and move it just a tad and hold and release. Let's do menu trace, graph trace, and put that cursor on there. So there's that maximum point. That's not where we're looking for. We're looking for where it hits the ground. So let's travel over. And it has said 0. That's how the calculator identifies our x-intercepts. They're also called zeros, which we'll study more as we solve quadratics. Okay, in the bottom right corner, we can see that 0 is identified as 8.665940. So we were told to round to the nearest hundredth of a second. Hundredth is 2 decimal places. We will look to the third to tell us how to round. So we have 8.665. The 5 says to round it up. 8.66594 was what was given. We are rounding to the nearest hundredth or 2 decimal places. So the 5 says round it up. We have 8.67 seconds. The second question says, using this equation, find out the time, so again, x value, at which the rocket will reach its max vertex to the nearest hundredth of a second. So let's go back to our calculator. I still have that trace tool on, so I'm just going to arrow over to the left and wait till it identifies that maximum point again. There we go. In the bottom right corner, 3.875, comma, 367.25. All right, we were asked about time, which is the x-coordinate, 3.875. We were asked to round to the nearest hundredth, so the 5 tells us to round it up. 3.88 seconds is when our rocket will hit its maximum height. And the third question, using this equation, find the maximum height. All right, maximum is going to be that vertex. Height was the y value of the rocket to the nearest tenth of a foot. So tenth is 1 decimal place. We'll look at the second to tell us how to round it. Let's go back to our graph. Looking at the y value of our vertex, the 367.25. Rounded to the nearest tenth, so hundredth says to round up, 367.3 feet. Right? Maximum height. So the vertex, the y value in feet, 367.3 feet. Of course, you know Delta Math is very particular about the rounding, so make sure you're reading those questions completely. There are a couple other ways that you can use features on your calculator to find your vertex or your zeros. Instead of the trace tool, again, a lot of students just prefer that tool. It's a really quick and easy most of the time to find the points that you need. So I'm going to hit escape to turn off that trace tool. Under the other calculator features, here's other ways you can find your vertex as a minimum or maximum. You can go to menu. Number 6 is analyze graph. And there we can see minimum or maximum. You do have to be specific. On our current graph, we have a maximum. It's going to ask you where you're looking. Our calculator is so powerful. It really needs help identifying the range or the section. This feature is good for any type of graph. And so some graphs have relative maximums, more than one maximum. So in the bottom left, it's asking lower bound. It just wants you to identify the left side of where the maximum is. You don't have to be all up on it. You can be further away. In fact, let me go ahead and do that. I'm going to place the point over here. If you're using the touchpad in the center, you would just, you can use the arrows to move it left and right, and then use the center button to hit OK. So I've hit OK, and now the question has changed to upper bound, or the right side. So I can just slide it to the right, and there it goes. It identifies our maximum. I'm going to hit OK, so it'll label it. There's that maximum point using Analyze Graph. I did choose, looking at our notes over here, I did choose maximum. I moved the dash line to the left of the vertex and hit OK. When it switched to upper bound, I moved the dash line to the right side and hit OK, and the vertex appeared on my screen as an ordered pair. You can do the same thing with those zeros or x-intercepts, again, under menu, Analyze Graph. What's good about this one is it labels it and sticks it there on the graph. So if you have to come back to refer to it, these are called zeros, or x-intercepts. And so I'm going to do the same thing. I'm going to hover on the left side of that zero. That x-intercept's about here. I'm going to be on the left side of it. And then when I hit OK, slide over to the right of it, and it is going to label that for me. And those are the steps I just followed. Analyze graph. Number 1 is 0. Move the dash line to the left of that x-intercept and hit OK. When it switched to upper bound, moved it to the right side and hit OK, giving it just a boundary area or region to look for that x-intercept. And that 0 or x-intercept appeared as an ordered pair on the screen. And I could repeat those steps if there is a second 0 or x-intercept. So just wanted to show you that as another feature, and especially if you want to label them and put them on your graph. Again, a lot of students prefer the trace because it is quick and easy and usually identifies all the important parts that we need when we are taking a test or a quiz. So there are some examples of quadratics in context. We started with some simple questions. Then when we were given the graph, identifying initial height, greatest height, seconds for how long it's been in the air and things like that. And then we moved on to our second page where we utilized our own calculator to create our own graph so we could interpret information for the context, looking at the company with the widgets and the rocket from the tower. Careful on the rounding, of course. You want to make sure that you're following those directions carefully, and just learning to navigate our calculator. You're going to see how many awesome tools there are there. The more you use that Inspire calculator, the more comfortable you will be using it and the quicker you'll be at it. So don't be frustrated or overwhelmed initially. It is a lot, but again, the more you use it, the more familiar you'll feel and the easier it'll be to use in time, okay? So guys, let me know if you have any questions. I hope that helped, and I'll see you in class.